Hello everyone and welcome to the Mathematiker channel. Arithmetic is full of seemingly obvious fundamental propositions which are quite tricky to prove. One of these propositions affirms that for every two natural numbers which are different from zero, any common divisor of those numbers divides their greatest common divisor. And reciprocally, any divisor of their greatest common divisor divides those two numbers. So, if a and b are two different from zero natural numbers, we would have the two following implications. First, if d is a divisor of the greatest common divisor of a and b, then d divides both numbers, a and b. And secondly, if d is a common divisor of a and b, then d divides the greatest common divisor of a and b. Let's start by proving the first implication, which is obvious and quite simple to prove. We already know that the greatest common divisor of a and b divides both numbers, a and b. So, there are two natural numbers that we can note, a prime and b prime, such that a equal the greatest common divisor between a and b multiplied by a prime and b equal the greatest common divisor between a and b multiplied by b prime. But because we suppose that d is a divisor of the greatest common divisor of a and b, then there is a natural number that we can note, d prime, such that the greatest common divisor of a and b equals d multiplied by d prime. By replacing the greatest common divisor of a and b in our first equalities by d multiplied by d prime, we would have a equal d multiplied by d prime multiplied by a prime, and b equal d multiplied by d prime multiplied by b prime. And this means that d divides both a and b. So this was how to prove the first implication. Let's see how to prove the second implication. The second implication states that if d is a common divisor of a and b, then d divides the greatest common divisor of a and b. Let's suppose that a is greater than b. We know that the greatest common divisor of a and b is the last rest different from zero that results from the successive Euclidean divisions of a over b. So, if we do the Euclidean division of a over b, we would have a rest that we can note, r1. By doing the Euclidean division of b over r1, we would have a second rest that we can note, r2. And after n Euclidean divisions, from the Euclidean division of r1 over r2, until we reach the rest 0, we would have done n plus 2 Euclidean divisions, and we would have n plus 2 quotients and rests. So, a would be equal to the multiplication of the n plus 2 quotients plus 1, all multiplied by the rest, rn plus 1. And b equals the multiplication of the quotients from q2 to qn plus 2 plus 1, all multiplied by the rest, rn plus 1, which is the last rest different from 0 and the greatest common divisor of a and b. Let's now reproduce these successive Euclidean divisions by taking into consideration the fact that d is a common divisor of a and b. We have a equal q1 multiplied by b plus r1. By replacing a by d multiplied by a prime and b by d multiplied by b prime, we would find that r1 equals d multiplied by a prime minus q1 multiplied by b prime. Let's note this number r1 prime. So, d divides r1. For the second Euclidean division, we have b equals q2 multiplied by r1 plus r2. By replacing b by d multiplied by b prime and r1 by d multiplied by r1 prime, we would find that r2 equals d multiplied by b prime minus q2 multiplied by r1 prime. Let's note this number, r2 second. So, d divides r2. As for the next Euclidean division, we would find that d divides r3, as it is the case with r1 and r2. And after we would have completed all our Euclidean divisions to reach the rest 0, we find that d divides the last rest different from 0, which is rn plus 1. So, this last rest, rn plus 1, which is the greatest common divisor of a and b, is divisible by d. And this proves our implication. So, now that we have proved both of our implications, we can conclude that our logical equivalence is true. Thanks for watching the video. We hope this was helpful understanding this fundamental proposition of arithmetic. If you have any remarks regarding this, let us know in the comments section.